We are going to be talking about the introduction to med math. Now, med math is critical to being a paramedic. You have to be able to do these different equations and be able to give the correct doses of medications in the field in stressful situations of emergencies. And so this is one of the more sort of challenging things with paramedic programs, or paramedicine, but is critical and absolutely something we're going to spend some time on. I need to start this conversation of med math off with making sure everyone understands that there's one really important challenge to med math for most people, in that we all have kind of different starting points on how we learned how to approach math problems. So you're going to find that this is going to be a case where you potentially don't approach math problems the way that I do. And then it doesn't make as much sense, and it's very hard for us to kind of understand what each other are doing, because math can be manipulated in a lot of different ways. So we need to start off this conversation just by understanding I'm not here to change the way that you do math, right? As long as you are able to make sense and get to the correct answers and have a logical reason how you got to that, then do your style of math. That's fine with me. But what you're going to find from me, and I'll give you the rationale behind it. There are really three main equations that are critical to be able to really do any task in med math that we're going to at least interact with. And for me, in stressful situations, in emergent situations, I find the best approach is simplify things as much as possible, because the more complicated something is, the more error or room for error there is. So you're going to find that I approach math in the most simple way. I have these equations, I plug in the numbers, and I just do the simple math. I don't take shortcuts. I don't try to manipulate things to make it, any different. I just do the equations. And that way, again, when all of my other sort of thoughts are on other things going on in the back of that ambulance, I can still just plug and play my equations. That's not to say you have to do it this way. That's the rationale for why I do it that way. So we will approach this throughout the semester, again, kind of figuring out the best methods for you to get to the answers of these problems. So let's start off med math with a really important concept of units and unit conversion. So you're going to find we're really, for the most part, working in the metric system. And so we're going to start to really kind of incorporate ourselves into that mentality. But we need to be able to take units and move them from, say, smaller units to larger units. So think like milligram to gram. So milligram smaller than gram. So if I'm moving from if I'm trying to figure out how, going from a smaller unit to a larger unit, what I'm going to do is I'm going to move that decimal point to the left. To the left. We're going to see how this works in just a minute. When I'm trying to break down a larger unit into a smaller unit, I'm going to move my decimal point to the right. The right. So this is a very fundamental thing that is important to understand. And we're going to take a look at this with this little table right here, or this little equation. Maybe you can look at it that way. So we're looking at our base unit here of 1 gram. So underneath it I wrote 1.0 G, 1.0 grams. And then we're going to kind of figure out how we convert this. So we'll start off by going to kilogram here. So what I'm doing here is I'm going for a gram to a kilogram. Kilogram is going to be a larger unit, grams is smaller. So I'm using this top equation, or this top idea first. I'm going from a smaller unit, a gram, to a larger unit, a kilogram. So as you can see here, I'm going to move my decimal point to the left. So what I'll do is I'm just going to draw a 1. And right here where my pointer is, that's where the decimal point would be if this was 1 gram. We're going to move it, in this case for a kilogram, 3 positions, 1, 2, 3, 3 positions over. So I'm going to do that, draw a 0 and a 0 there to fill this in. And what you're going to find is it's 0.001 kilograms equals 1 gram. 0.001 kilograms. I moved the decimal point over 3 places from gram to kilogram. So let's now use our same idea, but we're now going from gram to milligram. And for us, honestly, this is where we're going to, this sort of side of the equation, the gram, milligram, and microgram, this is where we're more interacting than we are ever really moving things over from gram to kilogram. So this is much more functional, what we're about to talk about. So in this case, I'm going from a gram to a milligram, a larger unit to a smaller unit. I'm going to move that decimal point to the right. As you can see here, we've kind of set the tone that you're going to be moving over 3 places. And so again, I'll draw my 1. And again, my decimal point would be here for 1.0. But again, I'm moving this over 3 places. So 1, 2, 3. And I'll fill in my zeros. 1, 2, 3. And that gives me 1,000 milligrams. 1 gram is 1,000 milligrams. Very simple. Just moving that decimal point over to the right 3 places. And I can do this again for a microgram. So in this case, I can say that, and we'll see this later, but this is, I can say that there is 1,000 micrograms in a milligram. So if I wanted to, I could say that we were saying this is a 1 milligram. And then this, I'll put my 1 here, and again, I'll do that 1, 2, 3, 1,000 micrograms, mcg, and that's 1 milligram. So I moved that decimal point over 3 places. Again, 1 milligram is 1,000 micrograms. But at the bottom here, what I really want to figure out is, well, how many micrograms are in a gram? Because remember, this is my base unit. So in this case, I'm not starting off with just that 1. I'm starting off with 1,000. A milligram is 1,000. A gram is 1,000 milligrams. So starting off there, and then now again 1, 2, 3, 0, 0, 0, and you can see here that in fact 1 gram is 1 million micrograms. 1 million micrograms. So this is how we are going to be moving our units. Everything is really, for our purposes, going to be moving over 3 places, either to the left, when you're going from smaller to larger, and to the right, larger to smaller. So let's see how this actually takes effect. Start off here at 1 milligram. So when I talk about 1 milligrams, as we kind of already just saw, 1 milligram is going to be the same as 1,000 micrograms. 1,000 micrograms. And if you see here, this is essentially the same problem. I just kind of shifted over to this 1 milligram to, or 1 gram to 1 milligram. So this is equally going to be just 1,000. 1 gram is 1,000 milligrams. But now we get into the kind of the tricky, oh, well, I have 100,000, 1 million micrograms. So we already saw that right here is the same thing as saying 1 gram. Now I'm talking about, this is still the metric system, but this is volume. So milligrams, kilograms, micrograms, all this stuff, we're talking about, weight of a drug. Now with liter, we're talking about volume of a fluid. So a liter, 1 liter, is going to be the same thing as 1,000 milliliters. 1,000 milliliters. You can almost substitute 1 liter as 1 gram and milligram as milliliter. So it still works on the same table. All of this, you can just change out for liter, milliliter, microliter, kiloliter. Same scale. And then finally, we have what is really actually a very functionally important conversion that we do have to talk about. That is different because we're actually changing now from our metric to our imperial system. And so the problem is most of your patients know their weight in pounds, not kilograms. And most of our drugs are weighted in kilograms. So we actually have to do a lot of conversion of pounds to kilograms in the field. So we can talk about this as the hard way. 1 kilogram is going to be equal to 2.2 pounds. So in this case, what I can do is I can take their weight that they tell me in pounds and divide it by 2.2. And if I have my calculator, maybe I can do that. That's very easy. And then at that point, just round up to the nearest, ones. So that's fine. But you know what? I like my life to be as easy as possible. And we actually have a little bit of a shortcut here for us in the back of the ambulance that is pretty much, accurate. You were talking about very minor difference between actually doing the equation of 2.2. So here's the little trick that is, again, accurate enough for us in the back of the ambulance. Let's say I had a 120-pound patient. And I want to try to figure out how many kilograms they are so I can give them their medication. Well, what I'm going to do is I'm going to divide that 120 by 2. And that's going to give me 60. But 2.2. So how do I get that other sort of factor, the rest of this in? So what the trick is, I'm just going to look at the tens place, and it's 6, and I'll minus 60 by 6. And that's going to equal 54 kilograms. So very simple. Pounds divided by 2 minus your result by the tens place. So that's the ones place, 0. Tens place would be 6. Hundreds place would be after that. So in this case, dividing by, or minusing by 6, roughly 120 pounds is roughly 54 kilograms. That's close enough for you to be able to do any of the actual, administration of medication that we have. So there's one that I just want to show you because this can get a little tricky. And that's, let's say I have my patient is actually 200 pounds. 200 pounds. So in this case, again, the same trick is going to work, but you're going to find that there's a little, a little bit of a modification we have to make here. So I will, again, divide that by 2, and that gives me 100. Well, now I have 3 numbers instead of 2 here. So what do I do? Oh, well, I'm just going to minus by the hundreds place. So in this case, I'm going to take 100 and minus by 10. Roughly speaking, 200 pounds is 90 kilograms. So again, when I have anything over 200 pounds, you're going to minus by the first 2 numbers, the hundreds and the 10. So in this case, that was 10. 100 minus 10 is 90 kilograms. Very quick, very easy in the back of that ambulance. Can knock that out.